Hold on, let's do this a little longer. I can't. Can. Which makes sense, because these objects don't take the... basically the matrices which encode the data about the panning. But that's still good, because it means if I do this in this example, if I just throw this in here, and then run the orbit controls. Okay, this is good. This shows the discrepancy between the objects that Grant wrote. Wait, no, there's something else up now. Because now, the square object isn't moving. Why? Oh, actually, I know why. And the reason why is because I overrode the methods. I overrode the methods that Grant wrote for updating the mouse information. So is there a better way to do this? I basically want to share these functions with the scene. Which would essentially be like adding an extra line to the ones that are in the scene. To call the ones that I wrote here. Okay, here's what I'm gonna do. For the ones on mouse drag and on mouse scroll, I'm just gonna write on mouse scroll 2. Which is, by the way, this isn't a very good habit of naming things like whatever underscore 2. But I'm gonna do it anyway. Okay. I'm just gonna move this into here. And give it the self.camera.model matrix. Okay, so that's good. Now I'm gonna try commenting this and this. And then from the regular on mouse scroll, I'll call the new one with, I guess, the same data, point and offset. Okay. No binding. What I do? 1207. Not there. Camera target. Oh, that's right. The target at which the camera is looking is saved like locally. It forms a closure around it. So I'm going to need basically this. Have to be an instance variable. Right here would be fine. And then this will be self.. Okay, see if that works any better. Oh, I ran the wrong example. Okay, so when I... No, scrolling still isn't doing anything. Why is that? It should call... That makes me think I'm not passing the uniforms correctly. Although that doesn't make much sense either. Let's see, self.camera.shift. I wonder if this one is overwriting the data. Let's see, self.camera.shift. I wonder if this one is overwriting the data. Doesn't look like it is. Here's what I'll try. I run the object test. Oh, and this one I can't even scroll. Oh, that's because I added this extra thing here, and that actually shouldn't be here for it to run the way it normally did. Scene.py 1212. 1212, so it was running this. What is self.opengl? Wait. Oh, I put self on the wrong thing. It should have just been opengl.translation matrix like this. So maybe now, not this. Maybe now the object test works without crashing. Nope, still crashes. I have to import the OpenGL utils, I guess. So import this. And this will be dot utils. From dot utils import like this. So now that should be imported. So now I'll see what it happens on the, not this test, but the object test. It worked. And now I actually see the problem. Scrolling doesn't even zoom with these controls. So why did I ever think that would do that? Okay. So why did that not happen with the orbit controls? What changed? Because in the object test, it's still calling the whatever 2. It's still updating this data on the camera. Yeah. So why did this change? Wait. OpenGL square, add the square. I feel like this will be really annoying to debug. Oh, I added an updater to the camera? That, I don't think that would change it. Alright, here's what I'm going to have to do now. I'm going to have to gradually transform the object test, this one, into the orbit controls test. And see when it stops working. So I can instantiate the shader. That won't cause any problem. I can... Whoops. Oh, one of my shortcuts doesn't work. That's annoying. I'll have to fix that one too. I can instantiate the attributes array and the mesh. That won't change anything, obviously. And I can add that mesh. Where is it? Here. Okay. And now it's doing both, actually. It's doing the scrolling from the perspective of the projection matrices that I wrote. Okay. And now it's doing both, actually. It's doing the scrolling from the perspective of the projection matrices that I wrote. And it's doing what Grant wrote. So if I add the updater, all I need to do is add the code that updated the projection matrices. And it should be working on both of them. On mouse drag. I don't even need this. This update camera function, I don't think it does anything. All it does is increment this time variable. So I'm going to go in scene, and I'm going to do the same thing with the dragging that I did with the scrolling. Namely, I'm going to take this code. Oh man, I keep thinking I have that shortcut. Drag this code. Bring it here. Put a 2 there, pass it with self. This will be self.camera target. And then here I'll just call self.onMouseDrag 2 with the same data. Point, D point, buttons. And let's see, somewhere in here, it's probably going to use the target. It's got to use the target, actually. And that's going to be self.target. And here. And there. Okay. And that's a crash. Import space ops, that should be easy. Here, I guess. It's importing individual things from space ops, which is probably better practice, actually. Okay. Okay, now it's doing both of them. Okay, so why didn't this happen before? If I can even do the scrolling for both of them. But you see these are out of sync, like they're doing totally different things. Like it can't rotate the square. Well, it can rotate it, but you know, the axes are different and stuff. Why wasn't that working before? In the orbit controls test. Like the scrolling didn't even work. Okay, the scrolling does work, but not the dragging. I guess I just had to add it to the scene. Oh wait, no, the square is not being updated again. Whatever, I probably just shouldn't care about this. I won't need the set attribute. I don't have to do that anymore. Maybe it is this updater. On mouse scroll. I can totally comment this now. Because that function is contained inside the scene now. At this point, These two functions are very similar. Now it's working. It must have been that set attribute. I guess that makes sense. Maybe the two, on mouse drag and on mouse scroll, interact with each other in some way. I guess that makes sense. Maybe the two, on mouse drag and on mouse scroll, interact with each other in some way. But in any case, this one, the mobject test, is now a better test to use. And it showcases the fact that I can't pan the regular mobjects. Which is why I'd like to get them working with the perspective transforms that I wrote. I think I'm just gonna remove this. Whoops. And honestly, good riddance. This was one complicated function. I ended up taking the code into the scene, so I guess that's good. But writing this function was a roller coaster. I'm also going to try to add an updater to the mesh. And that's fun. Okay, but now I'm going to delete this. For real this time. And this is a much, still sort of large, but a much more reasonable function. I should even factor out this mesh. This should be something like get plane mesh or something. Mesh. And this will just return that the axes I was using. So it's going to take this shader. This will be the default shader. I'll just return that. Then this mesh will be get plane mesh. Whoops. Oh my gosh. It's like all the small things I'm thinking I can still do and I can't. Okay, so I'll try running that again. And something didn't work. Because it needs a context. Okay, that should be good for that. Try that again. Cool. And now that code is a lot simpler. Basically just adding this square, adding this mesh. Most of the code is actually adding the updater to the mesh, which is good. Great. Okay. That's actually good progress, so I want to save those changes. And a lot of deleted code, thankfully. Oh, I should probably not call those do whatever to. No, that's fine for now. I'll say move orbit or controls into the scene and simplify examples. Great. So now I have to figure out what's the data to pass to this mobject in order for it to move the same way that these axes are, these planes are. I don't think it's a ton, but it probably will be. Let's be real, these planes are. I don't think it's a ton, but it probably will be. Let's be real. It's probably going to be terrible. But basically, if I open the shader that the vectorized objects use, close some of these. Is it quadratic? Bezier. Fill? I'll do the fill first. Okay, so here's what's sort of happening. Grant's camera and the camera I wrote they use different data to transform the points relative to the camera. What Grant's objects do is they use these two functions. Position point into frame and rotate point into frame. Which I'm not totally sure what those do either. Okay, so it's not a ton. Basically, you're going to take the point, you're going to pass in the camera's rotation, as well as the camera's center. And it's just going to rotate the point the same amount that the camera has rotated. Shouldn't it be the opposite? Because if the camera rotates one direction, then from the camera's perspective, the point would be rotating the other direction. But maybe... I guess he took that into account somewhere else. And then here... if the camera moves somewhere, it's going to subtract that translation from the point. So that makes sense. The shaders I wrote don't do this. Let me see if I can find it. The ones I wrote... where is it? Default.vert, I think, does it. The shaders I wrote take these matrices, which is the way it's normally done, and then multiply the point by these matrices. And these matrices encode the position and the rotation of the camera. So what I'm going to try to do is pass these matrices to the shaders that Grant wrote, and then use these matrices to transform the points. Wish me luck. I actually think just that change might crash the program. Well, it didn't, so that's good. So then the only thing to do is, oh wait. BP. Bezier control point. Which one is this? This is for the fill. Okay, so it's passing in all these points. And then it's positioning the point and rotating the unit normal. But it isn't rotating the point, and it isn't positioning the unit normal. I guess that makes sense. You wouldn't position a unit normal. Oh, this will be kind of annoying. Let me see if I can find where that unit normal is passed in. No, this could be kind of annoying. Let's go to the renderer. Okay, here. This is where the mesh is created from the data that was wrapped into the shader wrappers. So basically vertex data and indices. The uniforms, where are the uniforms done? Here? Okay. So if I render the square, I'd be able to see its data. Where are the uniforms done? Here? Okay. So if I render the square, I'd be able to see its data here. Let me look at that. What I'm gonna do is not add the mesh so that the square is the only thing in the scene, and then not do this so that my IPDB doesn't crash. I think I'll have to do a self.wait. And I'm gonna want to here, I'm gonna want to stop. And look at how that data is passed. So let's look at the vert data. So we got point, previous point, next point, unit normal, stroke width, and whatever. The indices aren't that important. So here are the points. Point, previous point, next point. Here's the unit normal. So the first problem is that all of these are 3 by 3. Both the points and the unit normal are 3 by 3. And these matrices are 4 by 4. So I'm gonna have to convert those into homogeneous coordinates. And that'll actually have to be the first step before even... because I can't even transform the points until they're homogeneous. And where's the best place to do that? I guess it's possible. Okay, here's where I think the best place would be to do that. When I get the shader wrapper, so it should be somewhere at OpenGL vectorized mobject. There's gonna be a place where I get a shader wrapper. Fill shader wrapper, which is the one I care about. Let's get this vertex data, get fill shader data. And this is where it passes in the unit normal, I think. Where does it compute this? Read data to shader, fill data, unit normal, unit normal. Where did it compute the unit normal? I fail to understand. What is read shader? Read data to shader. What does that do? It's probably just a utility function or something like that. Well, that didn't work. To here. So I'm gonna pass a buffer, then the name of the variable in the shader, then I guess the name of the variable on the mobject. It's gonna say shader data at shader data index at the shader data is self.data at data key. So it's reading this unit normal from self.data unit normal. here, which is 1x3 array. I think that's mostly okay. I think making this always be 1x4 is probably going to be really annoying. I think the better solution will be to convert it to a 1x4 right before it's passed to be rendered. Should I do it here in the mesh? Probably not. I think it should happen... Wait, where do I... Shader wrapper in the shader wrapper list. So here I get the shader wrapper list. Mobject.getShaderWrapper list. So